So next topic we are having rectilinear propagation of light. So what do you mean by rectilinear propagation of light? Here we are having the definition. In a transparent medium, light always travels in a straight line. Means, for example, here we are having any transparent object. Here we are having glass, here also glass, here also glass, and in front of transparent medium we are having a source of light. So whenever light from the source of light is entering into a transparent object, that transparent object will allow the light to pass in a straight manner or in a straight line. And this property of the light, whenever it is moving in a straight line, is known as rectilinear propagation of light. And whatever the applications of rectilinear propagation of light are there, many phenomena are there, like formation of shadow, images are formed due to the rectilinear propagation of light. Even though solar eclipse and lunar eclipse, maybe you have listened the words like Surya Grahan and Chandra Grahan. These two things are there, known as solar eclipse and lunar eclipse. These things are also occur due to the rectilinear propagation of light. And about the formation of shadows, formation of images, solar eclipse, lunar eclipse, these all things we will study in the last slides of this chapter. Okay. So next topic we are having applications of rectilinear propagation of light. As we have already studied about rectilinear propagation of light. So what do you mean by rectilinear propagation of light? Rectilinear propagation of light means the property of light in which light moves in a straight line through the transparent medium. This property is known as rectilinear propagation of light. And due to this property, there are three formations are there, or three applications are there because of this. First application is pinhole camera. Second application, we are having the formation of shadows. Shadows also form due to rectilinear propagation of light. And third, we are having occurrence of lunar and solar eclipse, or you can say Surya Grahan and Chandra Grahan. Okay. Principle of pinhole camera is rectilinear propagation of light. Formation of shadows principle is also this, rectilinear propagation of light. And the occurrence of solar and lunar eclipse principle is also rectilinear propagation of light. And this question is very important from exam point of view. Question will come like this. On which principle pinhole camera works? Answer will be this. On which principle formation of shadows form? Answer is rectilinear propagation of light, and same with the third, lunar and solar eclipse. So now one by one we are going to study all these the applications of rectilinear propagation of light. Firstly, we are going to start with the pinhole camera. So here we are going to study about the pinhole camera. So what do you mean by pinhole camera? See carefully. So whatsoever camera we are using in our daily life. So what this camera is doing? What the camera is doing? Camera is just clicking our picture, or we are taking the selfies from the camera. Okay. So this pinhole camera is also a type of camera, but it is the simplest type of camera. And the simplest type of camera is which? Pinhole camera. So what is a pinhole camera? See carefully. Why it is used? Pinhole camera is used to obtain the image of an object through the very small hole, or you can say through the pinhole. Means through this pinhole, whenever we are using the cardboard, and with the cardboard we are having very small hole, from the small hole we are able to take the picture or image of the object. And how it is working? It is just working on the principle of rectilinear propagation of light. When light travels in a straight line, only according to this principle pinhole camera works. If light travels zigzag, then there is no working of pinhole camera. Pinhole camera does not work properly in that case. Okay. So now we are going to study about the construction of pinhole camera. So actually a pinhole camera consists of a rectangular box. In a pinhole camera, actually rectangular box is there. At the one side of rectangular box, one film is there. Film, or you can say screen is there. Screen is there on the one side, and on the other side we are having a small hole. Okay, opposite to the film, opposite to this screen, we are having a small hole. This film is acting as a screen which is inside the box. Inside this rectangular box we are having a screen, and this box is blackened inside. All the surfaces or all the sides of the whole rectangle is blackened. Why it is blackened? So whatsoever light radiations are entering into the rectangle, that all light radiations are going to absorb into it, and whatsoever image is there, that image is going to form into the screen. This is the construction of pinhole camera. So next topic we are having working of pinhole camera. So how pinhole camera works, how it is able to capture the image of an object. So actually in a pinhole camera, first of all, object must be there. If there is an object in front of pinhole camera, then only the image will form on the screen. Okay. So how the image is forming? See carefully. So first of all, a beam of light from the top of the object passes through the pinhole and move toward the bottom of the screen like this. whenever the light radiation from the top of the object moves through the pinhole and enters into the bottom of the screen, and similarly from the bottom of the object, when in a straight line light ray will move from the pinhole and moves up toward the upside of the screen, it will form the image. Okay, in this way image is formed. But whatsoever image is forming on the screen, that image is upside down. Actually object is like this, but image formed is like this, or you can say inverted image is formed. Inverted means upside down image is formed, and the image is forming on screen, no? So whenever I told the images are forming on screen, that images are nothing but real image. So in pinhole camera, first of all inverted image is formed, and secondly image formed is a real image, means the image which forms on screen. So this is the working of the pinhole camera. Next we are going to see that on which factors size of the image formed by a pinhole camera depends. So mainly there are two factors on which the size of image formed by a pinhole camera depends. So very first factor we are having, it depends upon the distance of screen from the pinhole. Means whenever we are changing the distance from the screen and that of pinhole, the size of the image formed by a pinhole camera also changes. First factor we are having this, and second factor we are having, it also depends upon the distance of screen from the object. Means whenever we are changing the distance from the screen that of object, in that case also size of the image is going to change. So here we are going to study about the first effect, that how the distance of the screen from the pinhole on the size of the image depends. So how it depends, see carefully. If the distance of the screen from the pinhole is increased, for example this is, we are having simple pinhole camera. In simple pinhole camera this kind of image is formed. But yes, if I am increasing the distance from the screen and that of pinhole, this distance I am going to increase like this. So here distance increases. Whenever we are increasing the distance from the pinhole and that of screen, in that case size of the image is going to enlarge or increases. By increasing the distance, size of the image is also going to increase. Second method we are having, we can change the distance of the pinhole from that of object. Means if the for example this we are having simple pinhole camera, and whenever we are changing the distance or whenever we are increasing the distance from the pinhole to that of object, in that case the size of the image is going to decrease. Okay, increasing the distance between the pinhole and the object, size of the image decreases. So now here we are having the formula, that how we can find the size of image formed by a pinhole camera by using which relation. So here we are having the relation. This relation we can use in order to check the size of the image. Okay, this relation is like this: size of image over size of object. What is the size of image? That we have to write upside, over size of object we have to write downside, is equals to, here you have to write the distance of the screen from the pinhole, and downside in the denominator you have to write distance of the object from the pinhole. So by using this formula we can easily find the size of the image formed by a pinhole camera. This relation only you have to learn. Just you have to learn the formula, as in 6th class there is no numericals related to this. Okay, just learn this formula. So next topic we are having shadow. So what do you mean by shadow? Might be you have seen these kind of shadows in your daily life. So what is a shadow? Shadow is a darkness caused by a opaque object. For example, whenever we are having a source of light, and in between the source of light one opaque object is there. So what this opaque object will do? Opaque object will block the light rays into it. It will not allow the light rays to pass through it. So whenever light rays are going to block by the opaque object, in that case shadows form. And shadows always need a screen in order to make. Clear? The shadow is only the darker region of the opaque object. Black or grey color is there of the shadow, which does not contain any color and does not give any information about the object. So during the formation of a shadow, three conditions must be fulfilled. What are these three conditions? See carefully. First of all, we should have a source of light. If there is a source of light, in that case only shadows are formed. Even though if we are having point source of light also, in that case also shadows are formed, and shadows are formed very proper shadows are formed by a point source of light. Second condition we are having, second condition is an opaque object must be there. In between the light rays of the source of light, there should be an opaque object. That opaque object will block the light rays, and after blocking the light rays, there must be a screen. Where the shadows are going to form, screen must be there. Whenever screen is there, in that case whenever opaque object is going to block the light from the source of light, the blocking of the light ray by the opaque object will cast a shadow on a screen. So three conditions must be fulfilled. In that three conditions only the formation of shadow will be there, otherwise no shadow is there. So now only we have studied about the shadow. Actually whatsoever shadows are there, that shadows always contain two parts. What are that two parts? First part is we are having umbra. What do you mean by umbra? For example, here we are having a source of light, and in between the source of light and the screen we are having a opaque object. Whenever the light rays from the source of light are going to strike on the opaque object, these light rays are going to block by the opaque object. Whatsoever light rays are going to blocked by the opaque object, in that case umbra, or we can say darker shadow, is going to form. That darker shadow is nothing but called a umbra. And these light rays are there which are going to partially move from the opaque object, means these light rays are not going to block by the opaque object. Whenever light rays are partially moving from the opaque object, in that case lighter shadows are formed, and these lighter shadows are known as penumbra. So what do you mean by umbra? Umbra is the inner part of the shadow which is completely dark. This is known as umbra, and actually no light reach in this umbra region. But if we are talking about penumbra, penumbra is a partial darkness. Might be you are seeing this partial darkness. Actually partial darkness is surrounds the umbra. In the surrounding of umbra we are having the penumbra, and here in the penumbra region some light rays always reach in this region. So next topic we are having shadow formed by a point source of light. For example, when we are having a point source of light, what kind of shadow is going to form by a point source of light? So in a point source of light, these kind of radiations are going to move. These kind of light radiations are there. So in a point source of light, actually whatsoever light radiations are there, these all light radiations are going to block by the opaque object, because in a point source of light few light rays are there, and these few light rays are going to block by the opaque object. Whenever all the light radiations are going to block by the opaque object, in that case full-fledged umbra is there and no penumbra is there. Okay, so whenever a light coming from a point source of light falls on an opaque object, the shadow is uniformly dark, means from the upside till the downside uniformly dark shadows form, and there is a sharp edges at the end of umbra. Only sharp edges are there, means here also like this, and here also same kind of shape is there. As the shape of object, same shape of the shadow or umbra is going to form. And here in this case, whenever from the point source of light shadow is going to form, in that case only umbra forms, but here penumbra is absent. Next topic we are having shadow formed by a light source smaller than that of object. If we are taking smaller light source and we are taking larger object, what is going to happen in this case? See carefully. Actually in this case both umbra and penumbra are going to form. For example, here I am having a opaque object which is larger as compared to the source of light. Here I am having source of light smaller as compared to the opaque object. Whenever the light radiation from the point source of light is going to fall on an opaque object, in this case both umbra and penumbra forms. Okay, both umbra and penumbra is going to form whenever we are taking the smaller source of light as compared to the opaque object. But yes, if we are taking the screen away from that of the opaque object, in that case both umbra and penumbra is going to increase. Here you can see whenever we are taking the screen away from opaque object, whenever we are having small source of light, and the opaque object we are having larger, but in this case I have took the screen backside, means distance increases. Okay, so in that case umbra as well as penumbra size is going to increase. So now in this case I am going to take the opposite, means I am going to see that how shadows formed by a light source larger than that of opaque object. See carefully. Whenever I am taking the larger source of light, here I am having larger source of light, and opaque object I am having smaller. So in that case what is going to happen? In this case also both umbra and penumbra is going to form. Here also umbra is there and penumbra is there, but you can see the size of umbra is small than that of penumbra. Umbra is small and penumbra is large. This is a penumbra, outer region. Partial darkness is more and inner darkness is less, or umbra is less. Okay, so but whenever I am taking the screen away from that of opaque object, in that case the size of umbra means very much decreasing, gradually decreasing. Whenever I am taking screen away from that of opaque object, in that case umbra is going to decrease very much and penumbra increases. And now in this case I took the screen very away from that of opaque object, means here also I am having a larger source of light. Here also I am having a larger source of light, but in this case you can see umbra is there and little bit penumbra is there. Okay, umbra and penumbra both are there. But if I am taking the screen very much away from that of opaque object, in that case, so here in this case if I am taking the screen very much away from that of opaque object, see carefully what is going to happen here. So beyond the point, whenever I am taking the screen very much away from the opaque object, here the size of umbra is going to decrease very much, and whenever we are taking screen away and away from the opaque object, in that case penumbra become too much large, and when it become too much large means here penumbra is going to faint, or it is not going to visible that much. Because of this reason only, whenever birds or aeroplanes are flying in the sky, we are not going to see the shadow on the earth's surface. Why? Because they are very far away from that of the screen, or the source of light is very far away from that of object and the screen. That is why the penumbra or the umbra is very much faint or too much large. If they are too much large, we are not able to see that much shadow cast on the earth. Okay. So third application of rectilinear propagation of light, we are having eclipses. So what do you mean by eclipses? See carefully. As we know, earth is always rotating or revolving around the sun, and moon is always revolving around the earth. And one phase is there when these all sun, moon and earth, they comes in a straight line. Whenever earth, sun and moon comes in a straight line, in that case the moon, either moon casts the shadow on the earth, or sometimes earth casts the shadow on the moon. In that case, whenever there are some shadows formed on either earth or either on the moon, in that case eclipses are formed. So here we are having the definition for the eclipse. Eclipse means the formation of shadow of heavenly body on the other is called eclipse. Means whenever during the time when sun, moon and earth come in a straight line, in that case see carefully, whenever for example moon is coming in between earth and the sun. Okay, so here sun is acting like a source of light. So whenever in between the source of light and the screen one opaque object is there, obviously opaque object is going to cast its shadow on the screen. So in that case what forms? In that case eclipses are formed, or you can say the shadow cast by the earth or the moon is known as eclipses. So see carefully, according to this we are having two types of eclipses depending upon the position of sun, moon and the earth. Two type of eclipses are there, solar eclipse and lunar eclipse. In Hindi we are saying that Surya Grahan and Chandra Grahan. So here we are having the image for the lunar eclipse and this is the image for the solar eclipse. So now one by one we are going to study about the solar and lunar eclipse. So now we are going to study about the solar eclipses. So what do you mean by solar eclipses? So during the revolution of the moon, the sun and the earth, whenever this phase comes, that moon comes in between the sun and the earth. So here in this position, sun is acting like a source of light, moon is behaving as an opaque object and earth is acting like a screen. So whenever the light radiations from the sun is going to pass from the moon, so the moon is going to block the light radiations from the sun. Whenever the moon is going to block the light radiations from the sun, the moon is going to cast its shadow on the surface of earth. So whatsoever light radiations are coming from the sun and going to fall on the moon, whatsoever light radiations are totally blocked by the moon, in that case umbra region is going to form. And whatsoever light radiations are going to move partially from the moon, in that case penumbra region is there. This is penumbra region, this is umbra region. And the region of the earth which is under the umbra region, that region is known as total solar eclipse. In this case, in this part of the earth, total solar eclipse is there, and the region of the earth where there is a partial light, or you can say penumbra is there, in that case you can say partial solar eclipse is there. Okay, and this region is always, this umbra region is always observed on new moon day only. So next we are having lunar eclipses. So what do you mean by lunar eclipses? When earth come in between the sun and the moon, in that case lunar eclipses are there. So here sun is acting like a source of light, earth is acting like a opaque object and moon is acting like a screen. Whenever the light radiations from the sun is going to fall on a surface of earth, earth is blocking the light radiations from the sun. So whatsoever total light radiations are blocked by the earth's surface, in that case umbra region is there on the moon. And whenever moon is there in the umbral part, you will say that there is a total lunar eclipse. Okay, so next we are having, as long as the moon is the umbral region or umbra region, you will say that here is a total lunar eclipse. And when the moon is entering in the penumbral region, in that case you will say that partial lunar eclipse is there. And this lunar eclipse is always observed on full moon night only. So next our question is, can we see the eclipses with naked eyes, like this lunar eclipse or solar eclipse? Can we see with a naked eye? Naked eye means without wearing any glasses or all, we can see the lunar or solar eclipse. Our answer is, we can see the lunar eclipse directly. No problem, lunar eclipse we can directly with our naked eyes. But solar eclipse we cannot see with our naked eye, because solar eclipse are always forming too much light radiations or harsh light radiations which cannot be beared by our eyes. That is why either we have to use the goggles, or we can use either pinhole camera also you can use in order to see the solar eclipse, or you can use the X-ray sheets in order to see the solar eclipse. So next our question is, do other planets and satellites also form eclipses? So whenever the satellites come in between the sun and the earth, or it comes in between the sun and the moon, satellites and planets also cast the shadow in the space. So planets and their satellites also form eclipses.